Let us now do another example from the quadrilaterals chapter. And in this example, we have to show that the bisectors of the angles of a parallelogram form a rectangle. So obviously bisectors means it divides the angle into two equal parts. So this is the figure given to us. So we have a parallelogram ABCD. And in this parallelogram, there are four angles: angle A, angle B, angle C, and angle D. Each of these angles is being bisected by a line segment. So the bisector of angle A is the line AP. The bisector of angle B is the line BP. The bisector of angle C is the line CR. And the bisector of angle D is the line DR. And these bisectors of the angles meet at certain points. So for example, the bisector of angle A and the bisector of angle B meet at P. Okay, so bisectors of angle A and B intersect at the point P, which is here. The bisectors of angle B and C, which is this line and this line, that is BP and CR, they intersect at Q. The bisectors of angle C and D, they intersect at the point R. And the bisectors of angle D and A, they intersect at the point S. So we have these four bisectors of the four angles of the parallelogram ABCD, which intersect at the points P, Q, R, and S. And we have to show that these bisectors form a rectangle. Okay, so we need to show that the quadrilateral formed by the intersection of these bisectors PQRS is a rectangle. Okay, so we will prove this by looking at the four triangles which are formed inside this parallelogram by means of these intersections of the bisecting lines. So we have a triangle here, we have another triangle here, we have a triangle here, and another triangle here. Okay, so there are four triangles. We'll look at each of those triangles and apply certain properties that we have already learned in our previous chapters. And then to prove that PQRS is a rectangle, we need to show first of all that PQRS is a parallelogram, and then show that one of the angles of that parallelogram is 90 degrees. Okay, so we are going to find out each of the four angles of this quadrilateral PQRS, and then compare the properties of the quadrilateral, and first show that PQRS is a parallelogram, and then we can show that PQRS is a parallelogram in which one of the angles is 90 degrees. In fact, in this particular problem, we will show that we will find that all the four angles are 90 degrees, which means PQRS is a rectangle. Okay, so let's start with the first triangle in the figure, that is the triangle ASD, which I have highlighted here in red. So in triangle ASD, the angle DAS plus the angle ADS is half of the angle A and half of the angle D, right? Because AS and DS are bisectors of angle A and D respectively. So let me mark those angles. So angle DAS is this angle over here, and angle ADS is this angle over here. So DAS, which I marked in blue here, is half of angle A because AS is a bisector of angle A, and the angle ADS, which I marked here, is half of angle D. So the sum of DAS and ADS is half of angle A plus half of angle D. So we can take the half as a common factor, and we have half of angle A plus angle D. But if you look at the angles A and D here, which is this angle, the complete angle A and the complete angle D over here, these are interior angles formed on the same side of the transversal for the two parallel lines CD and AB. So we have the parallel line AB. I have drawn the AB here and the line DC here, and it's as if AD is a transversal for these two parallel lines, and angle A and D are the interior angles. So angle A here and the angle D here, which is given by this dark blue line, dark blue angle here, angle A and angle D. These are interior angles which are lying on the same side of the transversal. In this case, they are on the right hand side of the transversal. So therefore, from our property that the interior angles on the same side of a transversal add up to 180 degrees. So therefore, angle A plus angle D is 180 degrees. So we can substitute this 180 degrees in the summation for angle DAS plus ADS. So we get angle DAS plus angle ADS, which is half of angle A plus D, which we have written here. But angle A plus angle D by the interior angles rule is 180 degrees. So half of 180 degrees is 90 degrees. So we have got this angle DAS plus angle ADS, that is this angle, which I marked in blue, plus this angle also marked in blue. The sum of these two angles is shown to be 90 degrees. Next, we look back again in this triangle ASD. And in this triangle ASD, there are these three angles. So I'll mark the third angle here, so in green. So that's that angle ASD. The sum of the three angles inside a triangle is 180 degrees. Then that's a property of the triangle, which we call as the angle sum property of a triangle. So all the three angles inside the triangle add up to 180 degrees. So that means DAS, which is this angle in blue, plus ADS, plus this angle in blue, plus the angle ASD, which I've shown in green, all these three add up to 180 degrees. But DAS and ADS is 90 degrees, which we have already shown here. So from that, we can calculate the value of this angle ASD in green here. So the value of the angle ASD in green happens to be 90 degrees, which we take the 90 to the other side. So we get 180 degrees minus the 90 degrees, which is 90 degrees. So this green angle here is actually 90 degrees. So 90 degrees means we can draw it as an angle like this, okay? So we first show that the angle ASD is 90 degrees. But we also see from this figure here that the angle PSR is vertically opposite to the angle ASD. So this angle over here is also going to be the same as the angle ASD because they are vertically opposite angles. So the angle PSR, which is, I'll mark it with a different color, so yellow. So this angle here is the same as this angle here. So because ASD is 90 degrees, the angle PSR is also going to be 90 degrees. So we will have this as 90 degrees. So we mark this as a right angle. It is 90 degrees. So we have shown that the angle PSR inside this quadrilateral PQRS is 90 degrees, because PSR is a vertically opposite angle to the angle ASD. Okay, we will now look at the second triangle in this figure and arrive at similar conclusions and find the angle, find all the four angles inside the quadrilateral PQRS. So let's look at the second triangle. So the second triangle we are going to look at is the triangle BQC, which I've highlighted in red here, and we'll apply a similar procedure as we did in the previous slide. So again here, angle CBQ, which is this angle, CBQ is this angle here, and plus the angle BCQ, which is BCQ is this angle over here. These two angles, okay, if you add them, they are equal to half of angle B plus half of angle C, because angle CBQ is half of angle B because BQ is a bisector of angle B. And angle BCQ, which is this angle, is half of angle C because CQ is also a bisector of angle C. So therefore, we get angle CBQ plus angle BCQ, which is this plus this, as half of B plus half of C, which is half of B plus C. We take half as a common factor. Again, like in the previous case, the angles B and C are interior angles to the parallel lines AB and CD cut by the transversal BC. So angle B and angle C are interior angles on the same side of the transversal. So therefore, angle B plus angle C is 180 degrees. So sum of these two angles is 180 degrees, that is, which is here. angle B plus angle C is 180 degrees. We will substitute this in this summation for angle CBQ plus BCQ, which is half of angle B plus C, and B plus C is 180 degrees. So we get this sum CBQ, which is this angle in blue, plus BCQ, which is this angle in blue. The sum of these two angles is 90 degrees. Okay, and again we'll apply the angle sum rule for the triangle BQC, and we'll see that the sum of the three angles inside the triangle will be equal to 180 degrees, and we know the other two angles add up to 90 degrees, so the third angle must be also 90 degrees. So angle CBQ plus BCQ is 90 degrees, and plus the third angle BQC should give us 180 degrees. So from this we get the value of the angle BQC, which is this angle here, BQC. We are getting this angle as 90 degrees, which is a right angle. And again we notice here that the angle PQR is vertically opposite to BQC. So the vertically opposite angles are equal when two lines are intersecting. So we have this line BP and the line CR intersecting each other, and we have the angle BQC as 90 degrees. So the angle PQR is also going to be 90 degrees. So we will get this angle also to be 90 degrees. Earlier in the previous slide, we have already proven that the angle PSR is also 90 degrees. So we have proven these two angles are 90 degrees so far. And we'll go on to find the remaining two angles, which is the angle P and angle R as well, in a similar procedure. So we have got now in this particular page, the angle PQR is 90 degrees, which is this angle here. And we get it as 90 because PQR is vertically opposite to the angle BQC. Okay, now let's look at the third triangle and obtain the angle value for angle P. So the third triangle we are going to look at is the triangle APB, which I have highlighted in red again here. So in triangle APB, again, the angle PAB plus PBA, which is this angle over here, plus PBA is this angle over here. Okay, PAB is half of angle A, so this angle over here is half of angle A because AP is a bisector of angle A, and PBA is going to be half of angle B because BP is a bisector of angle B. So we get PAB plus PBA as half of angle A plus half of angle B. We take the half again as a common factor and we get half of angle A plus B. And again, the angles A and B here are interior angles on the same side of the transversal. So if we consider the lines AD and BC as parallel lines intersected by the transversal AB, then we have angle A and angle B as interior angles on the same side of the transversal, and we know from the property of interior angles on the same side of the transversal that these add up to 180 degrees. So we have angle A plus B is 180 degrees, so we substitute that in here and we get that angle PAB plus angle PBA, which is this angle in blue plus this angle in blue, is equal to 90 degrees. Now also in this triangle APB, the sum of all the three angles in the triangle should be 180 degrees. So the third angle is over here, that's our angle APB, and the sum of the three angles, which is PAB plus PBA plus APB, is 180 degrees. We know that the sum of the first two angles here is 90 degrees. So the third angle, which is angle APB, is also 90 degrees, which is 180 minus the 90. So we get this angle APB as 90 degrees. So we have got this angle as 90 degrees as well. And in the previous two slides, we have shown the angle PSR is 90 degrees and the angle PQR is also 90 degrees. So we have found so far the three angles of the quadrilateral PQRS, and found that these three angles are each 90 degrees. Now let's look at the fourth triangle in this figure and find the fourth angle of the quadrilateral PQRS. So the fourth triangle that we are going to look at is the triangle CRD, which is CRD, again highlighted in red here. So again in this triangle CRD, the angle RCD, which is this angle I'm highlighting in blue, plus the angle RDC, which is this angle here, okay, is going to be equal to half of C plus half of D, because the angle RCD is half of angle C, because CR is the bisector of angle C, and the angle RDC is half of angle D, because DR is a bisector of angle D. So we get angle RCD plus RDC is half of angle C plus half of angle D. And then again we can show that the angle C and the angle D are interior angles on the same side of the transversal for the parallel lines AD and BC intersected by the transversal CD. So we have these two as interior angles on the same side of the transversal. So therefore angle C plus angle D will have a sum of 180 degrees. So we can substitute that 180 in this summation for angle RCD plus RDC. So we get this summation of these two angles RCD and RDC as 90 degrees, like we have done before so far. Okay, now again we look at the triangle CRD, and we know from the rule of angle sum property of the triangle that the sum of all the three angles should be 180 degrees. So angle RCD plus angle RDC plus angle CRD, which is this angle over here, all these three add up to 180 degrees. And we know the sum of the two angles here is 90 degrees. So 90 degrees for the two angles plus the third angle is 180 degrees. So we get the third angle CRD as 180 minus 90, which is 90 degrees. So we have shown here that the angle CRD, which is this angle here, is also a right angle. It's 90 degrees. So therefore, it's a right angle. And previously, we have shown that PSR is 90 degrees, PQR is 90 degrees, and also SPQ is also 90 degrees. So we have found the four angles here, and all the four angles are so far shown to be 90 degrees. So now we want to show that this is a parallelogram first, and then we want to show that this is a parallelogram which turns out to be a rectangle as well. Okay, so what we have shown so far, we have shown that the angle PSR, which is this angle here, PSR is 90 degrees. The angle PQR is 90 degrees, which is this one. And the angle APB, which is, I'll mark it in a different color, APB is this, is 90 degrees. But APB can also be written as SPQ. So APB is 90 degrees, that is SPQ is also 90 degrees. And the fourth angle, which is CRD, which is this angle over here, is 90 degrees. And CRD, we can also write it as the angle QRS, right? QRS is 90 degrees, okay? So we have found all the four angles of this quadrilateral PQRS, and we find that all the four angles are 90 degrees, that is, they are all right angles. Now the question is this PQRS a parallelogram? Now, one of the rules for the parallelogram is that the opposite sides should be parallel. We have seen these theorems in the previous lessons, that a parallelogram is a quadrilateral in which the opposite pair of sides are parallel. And the property of the parallelogram is that the opposite pair of angles are equal. So we see here in this figure that the opposite pair of angles in this quadrilateral are equal. So we have PSR and PQR are 90 degrees each, so they are equal to each other. So they are an opposite pair of angles which are equal. Similarly, SPQ and QRS, which I've shown in red, they are another opposite pair of angles which are also both equal to 90 degrees. So since we have the opposite pairs of angles to be equal, and this satisfies the condition for a parallelogram. Okay, it's a parallelogram if the opposite pairs of angles are equal, and since this property is satisfied, we say that PQRS is indeed a parallelogram. And secondly, since the angle is 90 degrees, they are equal and also equal to 90 degrees, and we know that a rectangle is a parallelogram in which one of the angles is 90 degrees. In fact, we have proven here that all the four angles are 90 degrees. So therefore, PQRS is a parallelogram in which all the angles are 90 degrees, and therefore PQRS is a rectangle. So we have proven here that the bisectors of the angles of a parallelogram intersect in such a way that they form a rectangle. Okay, so we have shown this by analyzing each of the four triangles which are formed in this figure and applying some basic rules that we have learned in our previous lessons.